So I want us to continue again. Once again, I welcome you to this online lesson, Ambassador Foundation, and I will ask you, I request you once again, continue watching the many videos I have here for the sake of your knowledge on chemistry and physics. So today, or right now, let me continue with density. You just connect with the previous topic you just watched about the other physical quantities we have. So density is actually a derived quantity of mass and volume. So it is defined as the mass per unit volume of a substance. Density is denoted by a Greek letter rho. It looks like P. So it's given by mass over volume. And the SI unit of density is kilogram per meters cubic. How did we come up and say that the SI unit is kilogram per meters cubic? We picked the SI unit of mass, we picked the SI unit of volume, then, mass of volume is kilogram per meters cubic. Also, it can be represented in grams per centimeters cubic. Now, 1 gram per centimeters cubic is 1000 kilogram per meters cubic. That is how it is. If you have 1 gram per centimeters cubic, if you want to convert to kilogram per meters cubic, you simply multiply by 1000. That is how it should be actually. So what is there is this, that conversion from this and that. If you want to get from 1000 kilogram per meters cubic back to grams per centimeter cubic, you divide by 1000. For example, water has a density of 1 gram per centimeters cubic. That is pure water. So pure water again has a, in kilogram per meters cubic, it is 1000 kilograms per meters cubic. That is the density of water, for example. So that is how it should be actually. Let's look at these examples. The density of a substance is 15 grams per centimeters cubic. Express this in SI units. Express this in SI units. You simply multiply by 1000. You simply multiply by 1000. You will get 15,000 kilogram per meters cubic. You can still go ahead and show. Let me take you back. You can still go ahead and show that 1 gram per centimeters cubic is the same as 1000 kilogram per meters cubic. How is that possible? Convert 1 gram into kilograms. You will get 0.001 kilogram. Convert 1 centimeters cubic to meters cubic. You will get 1 million. Sorry, in reverse way, it's going to be 0.000001. So now when you take 0.001 kilogram, divide by now the volume, which is 0.00001, you get 1000 kilogram per meters cubic. Just convert 1 gram to kilogram. Convert 1 centimeters cubic to meters cubic, then divide. You will get 1000 kilogram per meters cubic. We are in question 2 here. The figure alongside shows a measuring cylinder which contains water initially at level A. When a solid of mass 11 grams is immersed in water, the level rises to B. You see? So we have to acquire that skill of observation. We observe very well the volume. Find the density or determine the density of the solid. So first of all, density is given by mass over volume. We have mass, which is 11 grams. Our role here is to find the density, the volume. It is 50 minus 30. Let's check it very well. 50 is at this point. So the readings at 50, the readings at point B is 48. It's 48 because it is 2 calibrations below 50. And the readings on this other side is 31, 32, 33. So it's going to be 48 minus 33. 48 minus 33, you get 15. So 11 divided by 15, you will get what is there. So, but the point is, know how to read, because in this case, that is at this point. So we are supposed to take it as 31, 32, 33. At point A is 33. Point B, we have because this part is 40, 45, 46, 47, 48. So it's going to be 48 minus 33. that is where we are supposed to be. Show that 1 gram per centimeters cubic is the same as 1000 kilogram per meters cubic. I think that one I've told you. You simply convert 1 gram to kilogram, convert 1 centimeters cubic to meters cubic, and you divide, you will get 1000 kilogram per meters cubic. Determine the density in kilogram per meters cubic of a solid whose mass is 40 grams and whose dimensions in centimeters are 30, 40, and 3. So very simple. Let's get the volume. 30 times 40 times 3. You get the volume. Density is given by mass over volume. 40 over the volume you have down there. Because 30 times 40 is 1200 times 3, that's 600. 40 divided by that 600. The answer you will get is in grams per centimeters cubic. Multiply by 1000 to give you now kilogram per meters cubic. Question 5. A wooden block of mass 20 grams is 4 centimeters wide, 3 centimeters thick, and 6 centimeters long. Calculate the density of the wooden block in kilograms per meters cubic. Calculate the density of the wooden block in kilograms per meters cubic. So you see now, in short, we just get it fast. There are two options. You can convert 200 grams to kilogram, then you convert the dimensions into meters, but the easiest is let's get the density in grams per centimeters cubic. Then from there we multiply by 1000. So 200 is the mass. Now the volume is 4 times 3 times 6. So you will get 72. So 200 divided by 72, you get your answer. Then you multiply by 1000. You get the answer in the SI unit, which is kilogram per meters cubic. So these are the solutions. I would urge you to go through it all through. These are the solutions. So check on this. You simply pause and then you confirm whether you really have the correct thing. Yes. Show that here we have whatever I was telling you how to show. Just follow. I have done it well for you. Question 4 is here. Let me not repeat myself. I have shown you how to do it. You just pause the video and you follow the procedure there and you will get it very correct. They are very simple things that no one can ever fail to get. They are very simple. Now let's get to what we call the density bottle. And here I urge you to just listen it keenly. Density bottle is a bottle that is used to find the density of solids and liquids. It is used to find the density of solids and liquids. That is what a density bottle does, and that is the diagram of a density bottle. As you can see it, that is the diagram of a density bottle. So now, how I'm going to take you slowly. First of all, starting with how can we handle density bottle? How do we use density bottle to find the densities? Please follow this. Now, as you can see, it's a small bottle with a small opening, with a stopper, and with a neck. The neck is meant to be handled, and I'll tell you why. Then the hole, this hole, allows excess liquid to get out. It allows excess liquid to get out. Let us look at the 3 precautions that you are supposed to take as far as density bottle is concerned. Precautions when using a density bottle. The bottle should be held by the neck when wiping it. Neck. When you hold at the body, the heat from your body will make the density bottle to expand. Precaution number 2. The outside of the bottle must be wiped dry carefully. Must be wiped dry carefully. Yes, because you can break it and you have to wipe it dry to avoid the issues of mass. There should be no air bubbles when the bottle is filled with liquid. There should be no air bubbles, because air bubbles, it means there is no liquid, but it is occupying space. It should be that there are no air bubbles. Those are the 3 precautions that you should always do when using a density bottle. A density bottle is used to measure the density of either liquid or solid. That one, I think I have said it earlier. Now I want to use this example So there is a cup you always use at home to take tea, to take milk, to take water, to take juice, whatever you are taking it as a solid, or I mean as a liquid, you can use to take it. The density of tea, the density of milk, the density of water may not be the same, or whatever the juice you are taking may not be the same, but the volume that cup will hold would be the same. If you take a cup which is 500 centimeters cubic, milk full, it will be 500. If you take water, it will be still 500. So meaning, regardless of the liquid you're putting in, the volume will remain the same. But trust me, the densities of the liquids you are taking are not the same. And if densities are not the same, even the mass or the masses will not be the same. If, for example, this density bottle is 10 grams when empty, just let's start from there. If it is 10 grams when empty, and then when you fill it with water, it gives you 50 grams when it is full of water. It means the water is 40 grams. Now, if I fill this bottle with a different liquid that is not water, maybe I fill it with ethanol, of course, which has a lower density compared to water, it will not be 50 grams, it will be something less than 50, maybe 40 grams. Meaning what? If it is 40 grams when filled with ethanol, then and it's when empty, it is 10 grams, then the mass of ethanol is 30. But when full of water is 50 grams, and when empty is 10, so the mass of water is 40 grams. That's how we do it. Now, in most cases, mark my words, in most, I'm not saying in all cases, in most cases, we use water as the reference liquid. We give you the empty density bottle, then when full of water. When full of water, if it is 50 grams, then you will just know the mass of water is 40 grams. And when the mass of water is 40 grams, we all know this. Every serious physics student, you know, there are people who are just physics students, but I'm talking to the serious physics students. They know that the density of water is 1 gram per centimeter cubic. So if the mass of water is 40 grams, automatically the volume would be 40 centimeters cubic. There's no lie there. Now, if the volume is 40 centimeters cubic, the volume of water that can fill this density bottle is 40 centimeters cubic. Any other liquid that can fill this bottle will be 40 centimeters cubic, regardless of its density. Now, water has assisted us to get the volume of the density bottle. Now we are okay. When we fill it with another liquid, our issue is just to measure its mass. After getting the mass, we subtract for the empty density bottle. From there, what do? We get the density of the liquid using mass over volume. Look at this example now. Let's follow it fully. The mass of a density bottle is 20 grams when empty. Each of these questions starts there. 20 grams when empty. 70 grams when full of water. And 55 grams when full of a second liquid X. The liquid X we don't know. Calculate the density of the liquid X now. Take the density of water to be 1 gram per centimeter cubic. Now, when empty, 20 grams. When full of water, 70 grams. So what is the mass of water? 70 minus 20. We get 50 grams. 50 grams is the mass of water that filled that particular density bottle. Density, tumeelewana ni 1 gram per centimeters cubic, it is given. So the volume of water is 50 centimeters cubic. Even when we fill it with liquid X, it will still be 50 centimeters cubic. If it is filled by water which is 50 centimeters cubic, what makes you think that a different liquid will be a higher volume. No, it will be the same volume. Now, you see, the role of water here has made us get the volume of the density bottle, which is 50. Even the volume of liquid X is still 50. Now, what we need to know, so that we can get the density of liquid X, is its mass, because already we have the volume, it is 50. So, let's do this. Let's just get now the mass of liquid X, because the mass of empty density bottle is 20 grams. When full of liquid X, it is, you subtract, it is 55. So the mass of liquid X is 35 grams. Density is given by mass of volume, 35 over 40. I mean over 50. Then you have it. That's the answer. Whatever you get there, that is it. You will get it in grams per centimeters cubic. But what is there is convert to kilogram per meters cubic, or you just leave it there. As long as there are no restrictions or directions, just move from there. So another question is what I've just displayed there, which I expect you to be going through. Now this one, we want to use it to measure the densities of solids. So at some point, this one requires you to think even better than this, than the previous question we have just handled. In an experiment to determine the density of a certain solid B, the following readings were obtained using a density bottle. 22 pole pole. Don't have a hurry. At the end of the day, we will get it. Mass of empty density bottle, 8 grams. Mass of a density bottle and solidity, 96 grams. Before niendelee, let me explain something to you from there. We put some solid B in the density bottle. It gives us 96 grams. But the mass of the empty density bottle, we have said it is 8 grams. So the mass of this solid B is 96 minus 8, which is 88 grams. But let me explain something to you. Solids exist in the states of matter and the properties that they have definite shape. Meaning what? They cannot occupy all the spaces of the density bottle. The solids that were put have not occupied all the space. There is still some space. Even if you put solid B until it feels like it is full, it's not. There are still some spaces within the solid that needs something to fill. And that something is a liquid. For example, water. If you put water until it is full, there are no spaces left because water takes the shape of the container. Solid does not take the shape of the container. That's why you fill it with solid D, but you will still be required to put what? To put some liquid to fill it. Now we have the mass of solid D. Let's move on now. The mass 30 grams, but it is also 30 centimeters cubic. You less from 80. The remaining 50 centimeters cubic was the volume of solid B. And you know the mass of solid B, 88 over 50. We are done. That's how it should be. As simple as that. You follow this, until you get to where we are supposed to be. Very simple. You will not fail this. There's an exercise here. Copy the exercise, try it, work on more examples. I refer you to use KLB. It has good examples on this. Work on that. There's no problem with it. So this one, a density bottle has a mass of 17.5 grams when empty. When full of water, its mass is 13.5. When full of a liquid X, its mass is 35 grams. If the density of water is 1,000, but that is 1 gram per centimeter square, find the density of the liquid X. In fact, this one is for the liquids. No much. Just be at ease. Work on it. This is what I was looking for. The density of mixtures. When it comes to density of mixtures, we can mix two substances with the different densities. The mixture will not be having either of the densities. It will be having a density in between the two. So we call it the density of mixtures. It can be two solids which have been heated and they made to form an alloy. And that alloy is what we call now the mixture. It can be two liquids like water and milk. It can be two liquids like water and ethanol. That is it. Now, if you want to get the density of mixture, simply get the total mass of the mixture and the total volume of the mixture. You deal with individuals. If it is water and ethanol, deal with water. Get the mass of water, get the volume of water. Go to ethanol, get the mass of ethanol, get the volume of ethanol. Add the masses, add the volumes. Apply this that it is given by total mass over the total volume of the mixtures. I have to give you an example here. For example, we have this example here where we have a mixture consists of 40 centimeters cubic of water and 60 centimeters cubic of liquid X. So far we have the total volumes. If the densities of water and liquid X are 1 gram per centimeters cubic and 0.8 grams per centimeters cubic respectively, calculate the density of the mixture. Just aside on your working space, write water. Write volume 40. Density of water 1 gram per centimeters cubic. Mass of water you find using the density and volume, you get 40 grams. Just aside, write liquid X. Volume 60. Density 0.8. Mass, mass is given by 0.8 times 60. 8 times 6. 48. Then total mass over total volume. I will show you. These are the workings. You will get your answer without even struggling. Don't struggle while working simple questions like this. There's another one here. A solution contains 40 centimeters cubic by volume of alcohol and 60 centimeters by volume of water. If the density of the alcohol is 0.79 and that of water is, it is the same equation. Follow the same procedure. Get it. The workings are here. I did it for you, so please follow them. Get your answer here. Lastly, but not the least, time. Time is a physical quantity. Time is measured in seconds. It is divided as the measure of duration between two events. It is measured in seconds. So somebody is wondering why not minutes and hours. Seconds is the SI unit of time. 1 second seems to be very small. 2 seconds seems to be very small. Athletes knows how 2 seconds is very long. For an athlete, 2 seconds. If you defeat someone by 2 seconds in a world record, that's a lot of time. So these are the multiples and the multiples of seconds. 1 minute is 60 seconds. 1 hour 600 seconds. 1 day is 24 hours, which is 86,400 seconds. 1 second is 100 cent-second. And 1 second is a million microsecond. Get that one very clear. We measure time using stopwatch or a stop clock, depending on the level of accuracy required. You cannot use a stop clock to measure time for 2 athletes running. You will not. By the time you are looking at the stop clock, it's over. We use a stopwatch, which is more advantageous. Stopwatch is easy to handle and read than stop clock. I know some of you are in high school, but you've never known how to read a stop clock. It's more accurate than stopwatch. 34 is the cent seconds. I saw somebody saying that 4 is the milliseconds. No, the third column there is the cent second. So here we have 10 minutes, 22 seconds, and 34 cent seconds. How do you record this time? First of all, convert the 10 minutes to seconds, which is 600, plus 22 seconds equal 622. Then 0.34. So first of all, the seconds here is 22.34 plus 600 to get 622.34. There's something here not going well. It is 622.34. Ignore these other 3 seconds. That is it. So that's well. Concerning the pendulum, we will do it when we will do it in Form 3. It's a mechanical question that we can do it very well. Yeah, so we will just do this. So I want to give you assignment. Of course, I will not read for you, but I'm just showing you revision exercise. You copy, you post the screen, you copy, you go here, do the same, you copy, do the exercise. If you get a question that you cannot do it, please take it to your teacher. Your teacher will assist you. If I am your teacher, I will assist you. You can still ask a question on the comment section. I will assist you. Or my team. We are a team. We are a big team. They are following. Ask a question. You will be answered. Not even me. You are alone. We are many. Yes. So question is still there. I'm just giving you some questions. There's another question. So you just post the screen. You copy them. We have that one over there. I don't know why the diagram is overlying on the statement. The total mass of water and the Eureka can before the metal was lowered. Yes, before the metal was lowered. Yeah. So it's well. I'm just scrolling for you to copy these questions. They're very nice questions. Just copy in your physics exercise book. You can even write the Ambassador Foundation exercise book.